This video is for test corrections on Unit 8, three-dimensional figures. Please remember to show all work on your test paper. Question number 1. The slant height of the square pyramid is 8 centimeters, and the length of each side of the base is 6 centimeters. Find the lateral area. All right, so let's go over to our formula sheet and get the formula for lateral area of a square pyramid. And I see that formula is LA equals 1/2 L slant height times P, the perimeter of the base. Right? In the directions, they told me that the slant height is 8. So this 8 right here is the slant height L. So the only thing we really have left to calculate is P, the perimeter of the base. Okay, this base down here is a square because it told us in the directions. To find the perimeter of any figure, you add up all the sides. If one side of this square is 6, then every side of this square is 6. So let's come draw it over here. So the perimeter of this square would be 6 plus 6 plus 6 plus 6, or 6 times 4. That would be 24. Let's come back and fill all of these values in. Lateral area equals 1/2 times 8 times 24. And if we go type that in Desmos, we get 96. Everything was being measured in centimeters up here. So the lateral area would be 96 centimeters squared. That would be answer choice C. Number 2. Round to the nearest hundred. What is the total capacity of the cone up here at the top and the cylinder down here at the bottom of the storage container? Capacity means volume. So we're going to calculate the volume of the cone. The formula for the volume of a cone is 1/3 pi r squared h. We're also going to find the volume, the capacity of the cylinder down here. The volume of a cylinder is pi r squared h. And once we get these two answers, we're going to add them together and then round to the nearest hundred. All right, so let's go focus on our cone up here at the top. For the cone up here at the top, the radius is 6. So we're going to plug in 6 and square it because the formula says so. The height of the cone up here at the top is 8. All right, for the cylinder down here at the bottom, the cylinder and the cone fit together perfectly, so the radius of the cylinder is the same as the radius of the cone. So we have pi times 6 squared, and the height of the cylinder is 10. All right, so let's go do these calculations. All right, 1/3 times pi times 6 squared times 8 is 301.6. For the cylinder at the bottom, we're going to type in pi times 6 squared times 10. And that volume would be 1,131.0. And then we're going to add these two together. 6 plus 0 is 6. 1 plus 1 is 2. 0 plus 3 is 0. 3 plus 1 is 4. And 1. We have to round to the 100. Okay, the number in the hundreds place would be this 4. The 3 tells that 4 to stay a 4. So our answer would be 1,400. We were measuring in meters, so our volume would be meters cubed. That is answer A. Okay, number 3 says calculate the surface area of the cone. So we want to go look on our formula sheet. The formula for surface area is pi r squared plus pi rl. All right, so let's see. We need the radius and we need the slant height. We have the radius. That would be 10. But we don't have the slant height. That's the hypotenuse of this right triangle. So we need to figure out that slant height right there using Pythagorean theorem. All right, so remember, c squared equals a squared plus b squared. We're looking for c, the hypotenuse. Okay, I'm going to let a be the 10 and b be the 24. And I'm going to go type that in Desmos and get the value of the slant height. And I got the slant height is 26. Y'all, all I did was I typed this in Desmos, but I replaced the L with an X. So I really typed in x squared equals 10 squared plus 24 squared. All right, we've got everything we need now to go substitute and find the surface area. All right, so we have pi times 10 squared plus pi times 10 times 26. And when I type all of that in, I got that the surface area is 1,130.97. Okay, so it looks like most of these answers were rounded to the nearest tenth. So let's come round to the 10th. The 9 is in the 10ths place. The 7 tells the 9 to go up. If a 9 goes up, it goes up to a 10, and you carry the 1. So this would actually round to have a surface area of 1,131.0 centimeters squared. That would be answer choice B. All right, number 4. Find the surface area of the square pyramid. Let's go check and see what information do we need to find the surface area of a square pyramid. My formula sheet tells me that would be 1/2 LP plus big B. All right, so we need the slant height L. The slant height is the height that slants down from the tip top. It's the hypotenuse of our right triangle. The slant height for this square pyramid is 18. All right, we also need P, the perimeter of the base, and big B, the area of the base. So we need to draw the square base. So it says it's a square pyramid. And we need to calculate the perimeter and the area for that square. All right, if one side of the square is 16, then every side of the square is 16. To find the perimeter, you just add all the sides. 16 plus 16 plus 16, however many I've said, 4 of them all together, would be 64. Big B, the area of that square is length times width. 16 times 16 is 256. All right, so we're going to take all these numbers and go plug them in. The surface area would equal 1/2 times 18 times 64 plus 256. All right, let's go type that in our calculator and see what we get. And I got that the surface area would be 832. We were measuring in feet. And because this is area, our answer would be feet squared. All right, let's go see if we can find that in our multiple choice answers. It is D, 832 feet squared. All right, question number 5. Given the triangular base prism, determine the surface area round to the nearest tenth. All right, first, let's go look up the surface area formula for a triangular prism. All right, on your formula sheet that's at the bottom left, the surface area is equal to HP plus 2 big B. The height of the prism is the segment that connects the two triangles together. Okay, so let's find the two triangles. Here's one triangle up here, and here's a congruent triangle in the front. Those are our bases. We have to find the length of the segment that connects those two triangles together. The segment that connects them together is 13, so that is the height of the prism. The other variables that we need to solve for are P, the perimeter of the base, and big B, the area of the base. So we need to go draw these triangles and calculate the perimeter and the area. All right, I think I've made that big enough. In this triangle up here in the front, the right-hand side is 8. The bottom side is 9. They didn't have room to put the left side up there because they also put the height in there. There just wasn't room. So you've got to go look on the back triangle. The left side is 10. We can get the perimeter of that triangular base right now. Add up all 3 sides. 10 plus 8 plus 9 would be 27. I think I did that in my head. I'm going to go double check. Yes, perimeter is 27. Now we've got to go fill in the height of the triangle. That would be the 7.6. To calculate the area of a triangle, you do 1/2 base times height. The important thing about the base and the height of the triangle, they're the two that meet at the right angle. They touch the right angle. Okay, that 7.6 touches the right angle as the height. The 9 touches the right angle at the bottom. So it would be 1/2 times 9 times 7.6. And that would give me area equals 34.2. I'm going to remember at this point, since I'm done calculating, that's really big B and my formula up here at the top. All right, so we're ready to substitute and get our final answer. Okay, the height of the prism was the 13. Perimeter of the base was 27. Big B, area of the base was 34.2. Let's type all that in our calculators and see what we get. And when I typed all of that in, I got that the surface area was 419.4. We were measuring in feet. This is area, so that would be feet squared. All right, so if we had to come over here and fill in the blank, look, the feet squared is already there. We would just have to type in 419.4. All right, let's see. Next, number 6. Determine the value of the diameter of a beach ball that requires 804.25 centimeters squared of plastic to cover it. All right, let's just stop right there. We'll round when we're finished. All right, when we're covering something up, that would be surface area. If you cover it, that is surface area. All right, we need to go look and see. Y'all, a beach ball would be a sphere. So we need the surface area of a sphere. That formula is 4 pi r squared. Now we need to make our substitutions. It says that it requires 804.25 centimeters of plastic to cover it. That number is the surface area. So we're going to take out the SA and replace it with 804.25. And then we're just going to write the rest of the formula. And the variable that we have left to solve for is R. To type this in Desmos, you're going to turn that R into an X. All right, so let's go type that in Desmos and see what we get. All right, and I got that X, which represents the radius, is 8.00001. All right, that means the radius is approximately equal to 8. But wait, there's more. They don't want the radius, they want the diameter. To turn a radius into a diameter, you double it. So the diameter would be 8 times 2, or 16. So the diameter of this beach ball would be 16 centimeters. All right, let's see. Which number is this? Number 7. A company is creating a new cylindrical container to replace its original cylindrical container. The new container will have 4 times the volume as the original container. The height of the new container will remain the same as the height of the original container. And they want to know, how does the length of the new radius compare to the radius of the original? All right, so all we're going to do here is we're going to manipulate the formula for the volume. I was looking to see what we were working with here, the volume of a cylinder. So go look that up on your formula sheet. The volume is equal to pi r squared times the height. All right, now this is a balanced equation. Whatever you do to one side of the equation, you've got to do the same thing to the other side to keep the balance. All right, so they say, first thing, the volume over here is going to be multiplied by 4. The height is going to stay the same. Pi is just a number. Pi can't change. It always stays the same. So the only thing that could affect the volume being multiplied by 4 is by looking at the value of the radius squared. So basically what this comes down to is an equation that we could solve. 4 equals x squared. Y'all, I want to go type this in Desmos, so I changed my R to an X. If you go type that in, you would get x equals 2. All right, so that means up here, the radius had to be multiplied by 2 because if we put that square on there, 2 squared would give us the overall effect of multiplying by 4. All right, so we know that the radius got multiplied by 2. Let's see, which answer is that? It's A. The new radius will be 2 times the length of the original radius. All right, let's see, what have we got next? A spherical paintball measures 1.5 centimeters in diameter. Already I'm thinking we've got a problem. I know for spheres, we don't need diameter, we need the radius. To get the radius, we take the diameter and we cut it in half. We divide by 2. 1.5 divided by 2 would be 0.75. They want to know how much paint is in it. When you figure out how much something will hold, that would be the volume. So we're really finding the volume of a sphere. The volume formula is 4/3 pi r cubed. So we are going to calculate 4/3 times pi times 0.75 cubed. And when I calculated that, I got 1.77. Okay, and that answer's right there. I was looking to see how to round, but y'all, it's right there. 1.77 is answer choice A. And the reason it's centimeters cubed is because we found the volume. All right, question number 9. A sphere has a radius 21 centimeters long. Find the surface area. All right, this one's pretty straightforward. This should be nice. Surface area equals 4 times pi times r squared. They tell us the radius is 21. So we're going to calculate 4 times pi times 21 squared. And that gives me 5,541.8. And let's see, we were measuring in centimeters. It's area, so that would be centimeters squared. That would be answer choice A. Number 10, how much material is needed to make this party hat whose radius is 5, the height is 12, and the slant height is 13? All right, they give us everything we need. We just have to decide to make this party hat fit on our head. Should we have a bottom down here that's been covered up, or is it hollow so it'll fit over our round head? All right, to put a party hat on, it needs to be hollow. And when you don't cover the bottom, that would be lateral area. So look up the formula on your formula sheet for the lateral area of a cone. That is pi times r times L. And they told us every single dimension in the direction. So let's go find the radius. The radius is 5. L is the slant height. And they tell us the slant height is 13. We just type all of that in and see what we get. Pi times 5 times 13 is 204.2. Okay, this is area. We were measuring in inches, so that would be inches squared. That would be answer choice B. Number 11, find the surface area for the cylinder. So let's go look up the formula off of our formula sheet. Surface area is equal to 2 pi r squared plus 2 pi RH. All right, so let's go find the radius. The radius is 3. So plug it in and don't forget your square. Okay, let's finish it up. 2 pi times the radius, which is still 3, times the height. The height is 7. All right, just carefully go type all this in Desmos. 2 times pi times 3 squared plus 2 times pi times 3 times 7. And I got 188.5. This was measured in feet. It's area, so that would be feet squared. All right, so let's see, which answer is that? Well, we don't know because they left the pi's in their answer. All we have to do is go type in Desmos. That isn't going to fit. Just go type in Desmos 51 pi. And that would be equal to 160.2. Does that match our answer? No. No match. So then you type in B, 63 pi. 63 pi is equal to 197.9. Does that match our answer? No, it doesn't. No match. So let's go type in 21 pi. That's 65.97. That doesn't match either. I hope it is D or I've messed up and we're going to have to go find my mistake. All right, let's hope for the best. 60 pi is 188.5. That is a match. So our answer is D, 60 pi feet squared. All right, let's see. What's next? Number 12. What is the approximate volume of a can? Y'all, a can is a cylinder that is 5 inches tall. That would be the height. And has a 2.5-inch diameter. All right, we know if they give us the diameter, we have to cut it in half to find the radius. That would be equal to 1.25. The volume for a cylinder is pi r squared h. All right, so let's substitute our values. Our radius is 1.25, and the formula says we have to square it. Our height was 5. So let's type this in Desmos and see what we get. Pi times 1.25 squared times 5 is equal to 24.5. They were measuring in inches. This is volume, so that would be inches cubed. And that would be multiple choice answer B. All right, number 13. The ratio between the volumes of two spheres is 27 to 8. What is the ratio between their respective radii? Okay, so we need to make a table. And the table for a sphere, which is three-dimensional, would go scale factor, area, and volume. The scale factor is just A to B. The area is A squared to B squared. And the volume is A cubed to B cubed. We have to decide, where do we put the 27 to 8? That's the volume ratio. So 27 to 8 is going to go in the last column. To be in this column, these numbers have been cubed. To uncube them, you cube root them. And that's going to go back up here in the scale factor. So we're going to cube root the 27 and the 8. All right, cubed root of 27 is 3. The cubed root of 8 is 2. To move these into an area box, we square each one. So we're going to square the 3, and we're going to square the 2. And that would give us 9 to 4. But y'all, this problem was pretty tough because they didn't come right out and tell us what to calculate. They said they want the ratio between their radii. You have to remember that a radius is just a straight line segment. Whoops. And when we calculate the ratio for any straight segments, look y'all, straight S, segment S, scale factor is what we're looking for. So the ratio of the radii would be the scale factor, which would be 3 to 2. And that's answer choice A. All right, number 14. The cargo space of the truck is All right. Oh, I'm with y'all. It's telling us that this cargo space back here is 2.44 meters wide. That's up here at the top. 2.76 meters high. I see that. 8.20 meters long. How many cubic meters of cargo space does the truck have? Cubic, meters cubed. They want us to calculate the volume. All right, the volume of a rectangular prism is length times width times height. All right, let's see. The length was the 8.20. The width was 2.44. And the height was 2.76. All right, let's go type all those decimal numbers into our calculator and see what we get. All right, when I did that, I got 55.22208. They rounded all their answers to the hundredth. That would be this 2. The second 2 tells that first 2 to stay as it is. So our answer would be B, 55.22. All right, number 15, find the volume of the pyramid. All right, so first thing we need to decide, what kind of base do we have? It has 4 sides, and we have 96 and 96. So that means it has a square base. So we need to look for the formula for a square pyramid. And we're doing the volume. All right, the volume is 1/3 big B H. All right, let's see. Inside of this square pyramid, I know there is a right triangle. Here's the hypotenuse, or slant height. And then we come across to the middle of the base, and then we connect to the tip top up there. Here's what that triangle looks like when we pull it out. We don't have the height. We do know the slant height is 52, and this bottom part only goes halfway across. Half of 96 would be 48. All right, here's my hypotenuse C. So we're just going to do C squared equals A squared plus B squared. 52 squared. My goodness, come on. 52 squared equals H squared plus 48 squared. Turn this into an X to type it in Desmos and go get your answer. And I got that X, which is the height, is exactly equal to 20. All right, so we have the height. Check. Now we have to find big B, the area of the base. All right, I'm running out of room. I wrote too big for my Pythagorean theorem, but we can do this. We just need to go draw a square. I can do that right up here at the top. That square base had dimensions 96 and 96. We need to find big B, the area of that base. To find the area, we do length times width. 96 times 96 is a number I don't know, but I've got my calculator, and it is 9,000 216. We have everything that we need to come plug into our volume formula. Volume equals 1/3 times 9216 times 20. Let's go type that in Desmos and see what we get. All right, when I typed all that in Desmos, I got 61,440. We were measuring in feet. This is volume, so that would be feet cubed. All right, if we were going to go fill in the blank, they've already got the feet cubed for us. So we would just have to type in 61,440. All right, let's see. What's next now? Number 16. Quadrilateral GHJK and CVBN are similar. All right, so we need to make a chart. And for a flat quadrilateral, your chart looks like this. It goes scale factor, perimeter, and area. All right, and they want us to put the GHJK first and the CVBN second. So we got to keep our numbers straight as we fill them in. Okay, the area of GHJK, that should go up top, is 250 feet squared. Area should go out here in this last box, 250. All right, the area of CVBN, that would be the bottom number, is 10. We have to reduce that. 250 divided by 10 would reduce to equal 25 to 1. All right, to be in an area box, this has been squared. To take it back to a scale factor, we have to square root it. So we have to do the square root of 25 over 1. And that would give us 5 to 1. The perimeter is exactly the same as the surface area. So the perimeter ratio would be 5 to 1. All right, let's keep reading. Okay, I don't know what happened to my computer just then, but that's okay. The next thing they tell us is the perimeter of GHJK is 90. So y'all, they want us to use this perimeter ratio right here. So we're going to put 5 over 1. All right, now we have to put that perimeter of GHJK with this 5 over 1. GHJK goes up top, so that 90 goes up top. We have to find the perimeter of CVBN. That would be our X down in the bottom. Cross multiply 5 times X equals 1 times 90. Go type that in Desmos and see what you get. Miss Odell would be so disappointed in me, y'all. She taught us that we should hug up the things when we cross multiply. Here you go. I've got you 5 times X equals 1 times 90. We should keep our good habits. I always forget that, to be honest. And if we go calculate that answer, we would have X equals 18. X represented the perimeter of CVBN. So the answer in the blank right here is 18 feet. All right. I love those problems. They're my favorite in this unit. I love to cross multiply, and I love making the charts. Okay, number 17. Let's keep on going. 17. The circumference of a woman's spherical basketball is about 28 inches. Y'all, you know I'm awful at drawing these things, but I'm going to try to draw a sphere. It's going to be bad. All right, here's your sphere, and it kind of goes like this, and like this in the front, and here's your radius. What shape is that in the middle? Go away. That is just a circle. So when they say the circumference, they're talking about that circle right there. On your formula sheet, the circumference of a circle is 2 pi r. They tell us that the circumference C is 28. So we're going to solve this equation. We're going to take out the C and put in 28 equals 2 pi r. We're going to change that r to an x. And let's go see what that gives us. That would be about 4.5 if we round to the 10th. So r, the radius, is about 4.5. Now, for the final answer, they want us to find the volume of the basketball. So go look up your volume formula. That would be 4/3 pi r cubed. All right, let's go type all that in Desmos. 4/3 times pi times 4.5 cubed is equal to 381.70 inches. Volume is cubed. But they want us to round to the 10th. What would this 0 tell that 7 to do? It would tell it to stay a 7. So the volume of the basketball is 381.7 inches cubed. All right, number 18, fill in the chart. All right, to turn a similarity ratio into a surface area, we have to square each number. To turn a similarity ratio into a volume ratio, we have to cube each number. So we start with 1/2. A is 1, B is 2. If we square each number, we would get 1 to 4. 1 squared is 1, 2 squared is 4. 1 to 4. To turn the similarity ratio into a volume, we have to cube each number. A is 1. 1 cubed is 1. B is 2. 2 cubed is 8. So the volume ratio would be 1 to 8. All right. For the second box, they started us with the surface area ratio. That means these numbers have been squared. That means A squared is 49 and B squared is 81. To go backwards, we have to square root them. The square root of 49 is 7. And the square root of 81 is 9. So that means A is 7 and B is 9. To move way out here to the end, to be a volume ratio, we have to cube each number. 7 cubed is 343. 9 cubed, I don't know. I'll always have to go look that one up. That's 729. So this ratio would be 343 to 729. Right, and finally, the last row, they've given us the volume ratio. Those numbers have been cubed. A cubed is 125. B cubed is 216. To uncube them, we take the cube root. And the cubed root of 125 would give us A is 5. The cubed root of 216 would give us B is 6. Now to turn these into an area ratio, we have to square each number. 5 squared is 25. And 6 squared is 36. So our area ratio would be 25 to 36. All right, this is a great big mess everywhere. I'm going to go highlight the final answers in blue. For the first row, it would be 1 to 4. For area, 1 to 8 for volume. Second row, similarity ratio is 7 to 9. Volume ratio is 343 to 729. I lost my last row. I've got so much going on. Last row, similarity ratio would be 5 to 6. Area ratio would be 25 to 36. Again, I love doing these charts. They're my favorite, but that was just a little bit too small for me to keep all my work straight. All right, let me know if you've got any questions on that one. Number 19. Yes, find the surface area. All right, surface area equals 2 times L times W plus 2 times L times H plus 2 times W times H. The length is how long it is across the front. The width is front to back. The height is top to bottom. So you just type all these in. Carefully go type them in Desmos and get your answer. All right, length is 9, width is 6. All right, width is 6, height is 3. So go type all of that into Desmos, and you should get for number 19 that the surface area is equal to 198. Everything was measured in meters, so this would be meters squared. And I'm just checking my calculations real quick before I move on. Definitely surface area equals 198 meters squared. All right, number 20. A cone with a height of 10 inches has a volume of 30 pi inches cubed. Y'all, we got to pay attention to every little detail. A lot of you lost the pi. Oh my gracious goodness, that was supposed to be my highlighter. You lost the pi on that 30. And we're talking about volume. So we want to go get the volume formula of a cone. That would be 1/3 times pi times r squared times h. We're going to take out the v and replace it with 30 pi. We're going to leave the 1/3. We're going to leave the pi. We've got to find the radius, so that's going to stay our variable. And they tell us the height is 10. All right, change this r right here to an x and go type it in Desmos and solve for x. All right, let's go see what we get. Don't forget the pi. That's what I saw a lot of you forgot to do when I checked your work. And if we solve that, we get that the x is equal to 3. The x represented the radius. Therefore, the radius of this cone would be 3. And let's see, they measured in inches. So 3 inches would be the length of our radius. All right, number 21. How many times larger is the volume of a cylinder if the radius isn't changed, but the height has doubled? So we need to go get the formula for the volume of a cylinder. Volume of a cylinder is equal to pi times r squared times h. The radius stays the same. Pi can't change. It's just 3.14159. So the height is doubled. That means it got multiplied by 2. All right, so y'all, you just look at this and see what happened to the volume. If the height got multiplied by 2, and to keep the balance, that means the volume also has to get multiplied by 2. So that means the volume also got 2 times larger. Y'all, if they had said the height had gotten multiplied by 5, that means the volume would have also been multiplied by 5. It's just an algebra equation. Whatever you do to one side, you've got to do to the other side as well. Okay, but it wasn't 5. It was doubled. Doubled is times 2. Okay, let's move on. Number 22, determine the surface area of the triangle-based prism given its net. I'm going to make this really big. All right, so what we need to do is, well, y'all, you could do 2 ways. You could try to use the formulas, but if they give us the net, we should just find the area for each shape and then add them all up. This is a rectangle. The area of a rectangle is length times width. The length is 5. The width is 10. So this rectangle would be 50. Okay? To fold up, the rectangle over here on the right-hand side would have to be the exact same thing. It would have to be a length of 5 and a height of 10. 5 times 10 would be 50 for this rectangle as well. All right, if this height is 10, that means this height is 10. Let me go get a highlighter. All of these heights would be 10. The width down here at the bottom is 6. So this rectangle would have dimensions 10 times 6, or 6 times 10. This rectangle would have an area of 60. And finally, if the bottom down here, this purple side, if it's 6, what does the top one have to be? It also has to be 6. So the area of this triangle would be 1/2 times its base, 6, times its height, 4. That would give us 12 for this triangle at the top. And the triangle at the bottom has to be the same thing, so it would also be 12. The total surface area would be all of these individual areas added together. All right, let's don't miss any. All right, so we would have 12 plus 12, they're the two triangles, plus 50 for the right rectangle, plus 50 for the left rectangle, plus 60 for the rectangle in the middle. All right, let's add those up. 10, 11, 12. 184 is what I got in my head, but I want to go double check that in my Desmos. And that is correct. The total surface area would be 184. We were measuring in inches. So the surface area would be 184 inches squared. All right, we'll make this back normal size. All right, and let's see, what do we have next? Number 23. The circumference of the base of a cone is 9 pi inches squared. The volume of the cone is 27 pi inches cubed. What is the height of the cone? All right, again, I know I don't draw very well, but I'm going to try to make us a cone. And they're talking about the base of the cone. Oh my gracious, why does my highlighter never want to work? They're talking about the base of a cone. That base is just a circle. They're talking about the circumference of that circle. Circumference is equal to 2 pi r. They tell us the circumference is 9 pi. So we're going to take out the c and replace it with 9 pi. We're going to solve for r. If you want to put this in Desmos, you have to change that r to an x. And you would get x equals 4.5. Therefore, the radius is 4.5. But that answer's not over there, so I must not be finished yet. Now they want us to go work with the volume of the cone. The volume of a cone is 1/3 pi r squared h. We know the volume, we got to be so careful here. This could not have cut off at a worse place. The volume is 27 pi. So we're going to take out the v and replace it with 27 pi. We just found out the radius is 4.5. So we plug that in, 4.5 squared. They want us to find the height. That is the variable we have left, so we are in really good shape. We're going to type this in Desmos, but we're going to replace the h with an x. So here's what you type in Desmos, 27 pi equals 1/3 times pi times 4.5 squared times x. Okay, don't forget any of your pi's. Be really careful when you type this in. And when I did that, I got x equals 4. Therefore, our radius, I'm sorry, y'all, I totally messed that up. Not our radius. What were we finding? The height equals 4. All right, and the height is 4. That would be answer choice B. Okay, we are not going to go over number 24. That was a 0-point question. We had to do this because it was part of the big 3, but we didn't count it, so we're not going to count that for test corrections or grade recovery. You may omit this question. You will get full credit even if you don't show any work for this question because it was worth 0 points. All right, so I think we are on the very last question. It says a rectangular prism has a volume of 20 cubic feet. All right, so I need to do my best to draw us a rectangular prism. Y'all, here's how I learned how to draw these way back when. You make two rectangles that look congruent, and then you connect diagonally to the edges. And I'm going to color in the base to try to give us some perspective. Here's the bottom down here. So this would be the length, this would be the width, and this would be the height. All right, we know the volume formula is length times width times height. We know the volume, they give that to us, is 20. All right, each side of the base will be tripled. Only the base down here. Each side of the base will be tripled times 3. What are those dimensions? That would be the width. The width is going to get multiplied by 3. The other dimension down here at the bottom would be the length. The length would be multiplied by 3. The height's not affected because it's not part of the base. It stays the same. The overall effect, if we multiply the length by 3 and the width by 3, look, that's times. This side over here is going to get multiplied by 9. This is just a balanced equation. If the right side got multiplied by 9, that means we have to also multiply the left side by 9. 20 times 9 would be 180. So the volume of the new prism would be 180 cubic feet. And the last question is the bonus. You do not have to correct the bonus to get test corrections. So we're going to omit this one for test corrections or grade recovery. That means we can be done. All right, if you have any questions, please let me or Miss Odell know. Again, show all of your work so that you can get a really good test correction or grade recovery grade for Unit 8, three-dimensional figures.